Hello everyone. In this video, we continue to talk about the optimum portfolio weights. In a previous video, we discussed the optimum weights for a two-asset portfolio with an objective of minimizing risk alone. We now turn our attention to optimum weights when we are considering the overall portfolio performance, which includes return as well. We are not going to discuss the second case, this one here, which is to minimize risk subject to a given return. Why we are not going to do this in this video is because I have already done a series of 3 videos on global minimum variance, and you can watch those videos to see how we set up a Lagrangian function to solve for optimum weights. This was drawn from Dr. Harry Markowitz's framework. What we are going to do in this video is to try and find portfolio weights for a two-asset portfolio which are going to maximize the Sharpe ratio. So we are discussing the third case. It is important to note, however, that when we consider risk and return, both these methods are going to give us similar results, this method and this method. So let us begin dealing with the third case here, this one. Let us write down our objective function. What we want to do is that we want to maximize the Sharpe ratio for the portfolio with respect to weights. And our Sharpe ratio is equal to the expected return on the portfolio minus the risk-free rate, which is our excess return, divided by the standard deviation of the portfolio. To keep things manageable, we are going to define a couple of variables. Because a two-asset portfolio is going to be comprised of two assets and their returns, we are going to define the excess return on asset 1 as capital R1, and we are also going to define the excess return on asset 2 as capital R2, so that we don't have to write R1 minus RF and small r2 minus small rf every time. Using these definitions, let us rewrite the Sharpe ratio. We are writing this part first. The excess return on the portfolio is going to be simply equal to W1 times R1 plus W2 times R2. Now we are going to write the standard deviation, but I am going to take it upstairs. Therefore, I am going to multiply the standard deviation by writing W1 squared times variance of the first asset plus W2 squared times the variance of the second asset plus 2 times W1 W2 times covariance between the returns of the two assets. And because I have taken this upstairs, I am going to raise it to the power of minus half. What we are going to do now is to take the partial derivative of the Sharpe ratio with respect to W1. So let us start doing that here. If you look at this function now, you see that it's a product of two functions. So we are going to have to invoke the product rule of differentiation. Also, you will see as we move on, we are going to also use the chain rule. What is the product rule first? The product rule says that if we are taking the derivative, we write the first function as it is and multiply that with the derivative of the second function, plus we write the second function as it is and then we multiply that with the derivative of the second function. So let us do it. We write the first function first as it is. We are going to multiply this with the derivative of the second function. But the second function is going to ask us to use the chain rule. So let us do that here. We write the exponent and then inside the bracket we write the inside function as it is, which is basically the portfolio variance. So let me finish writing that. And we are going to raise this to the power of n minus 1, which is going to be minus 1 over 2 minus 1. That is going to give us minus 3 over 2. We are not still done differentiating the second function because we need to multiply this with the derivative of the inside function. So we write a dot and write down the differential of the inside function, which is going to be from this term 2 times W1 times variance of 1 plus, we don't get anything from here. From this function we are going to get 2 times W2 times covariance between 1 and 2. So we have done the first part, the first function as it is times the derivative of the second function. Now we need to write a plus sign and write the second function as it is, which is again the portfolio variance. So let me finish writing that. So this is the second function as it is, and we have to multiply this by the derivative of the first function. The first function is this, and from this term we are going to get R1. From the second term we are not going to get anything. Now let us do a couple of tricks. We see a minus 3 over 2 power here and we want to get rid of it. So what we are going to do is that we are going to multiply throughout. By this term here, which is the portfolio variance, raised to the power of half. So let me write it here for you. When we multiply this entire thing on the right hand side by this term, let us see what we are going to get. From this whole term, let me highlight it in red because there are too many items. From this term, when we multiply by this term, the exponents, this one and this one, are going to get added. And when they get added, they are going to leave us with an exponent of minus 1 here, which is much more manageable than minus 3 over 2. And when we multiply this term with the second item here, this is going to give us, it looks like I made a small error here. Let me correct it first. This term was supposed to be the variance, to be the standard deviation, which was this second function here. So I omitted writing the minus half power here. I'm going to write that here. So this means when we multiply now this term throughout with this term here, the exponents, this one and this one, are going to get added, which means that the exponent is going to become 0, and anything raised to the power of 0 is 1. So that is going to take away this term altogether, and we are going to have only R1 left with us. Let us write it out. Let us write down the first term. We have W1 times R1 plus W2 times R2. What else do we see? We see that there is a 2 here, which is going to cancel out with this 2 here and this 2 here. And the power of this term, we said a little while ago, is going to be minus 1. So we are going to have a negative sign from here, this one. So we will write that. And then we are going to write the portfolio variance, portfolio standard deviation. Well, this would have been the portfolio standard deviation, but now, because we multiplied this term with this, the exponent is minus 1. After that, we have this item remaining here, so let's write that. W1 times variance of 1 plus W2 times covariance between 1 and 2. So we have dealt with the first term. From the second term, we said that this whole thing is going to vanish, because minus 1 over 2 plus 1 over 2 is going to give us an exponent of 0, and anything raised to the power of 0 is 1. So 1 times R1 is going to give us R1. So we write a plus and just write the R1 here. Now let us see what we can do. We can write this whole term as a fraction. We can take this term down into the denominator, so that this power is going to become plus 1. So what we are going to have on the numerator? We are going to have this item. What else are we going to have? We are also going to have this item. So let us multiply. W1 times variance of 1 plus W2 times covariance between 1 and 2. We also have this minus here, so we'll write a minus sign here. And on the denominator, we are taking down this term. And since it's raised to the power of 1, we just leave it like that. And after that, we have this plus R1. We can write this as this: minus W1 times R1 plus W2 times R2 times W1 times variance of 1 plus W2 times covariance between 1 and 2 plus R1 times this term. We are doing that because then this denominator will be applicable to the entire set of things here. So R1 times W1 squared variance of 1 plus W2 squared variance of 2 plus 2 times W1 W2 times covariance between 1 and 2. There was a covariance between 1 and 2 here as well, and a covariance between 1 and 2 here as well. Things get pretty messy, so it's easy to forget. So we have to be a little careful when we are doing this. So now this whole thing can have one common denominator. We can set this all equal to 0. By setting it equal to 0, we are effectively getting rid of this item here, because when it goes to the right hand side, gets multiplied by 0 and vanishes. So what are we going to have? We are going to have now with us, I'm going to write this term first because this is the positive term, R1 times W1 squared times variance of 1 plus W2 squared times variance of 2 plus 2 times W1 times W2 times covariance between 1 and 2. And then I'm going to write the negative term, which is the product of these two terms here. So let me write that here. And this is all equal to 0. Now let us see what it looks like. Let us multiply out and open the brackets. R1 times this is going to give us W1 squared R1 times variance of 1 plus we are also going to have W2 squared times R1 times variance of 2 plus we are also going to have 2 times W1 times W2 times R1 times the covariance between 1 and 2. So we have multiplied out these items. Let us do that for the second term as well. So we write a minus W1 R1 times this is going to give us W1 squared times R1 times variance of 1. This times this term, and we have a minus outside, is going to give us W1 times W2 times R1 times covariance between 1 and 2. Now let us look at these terms. What we are going to have here now is W2 times W1 times R2 times variance of 1, and we have a negative sign outside. So we have here W1 times W2 times R2 times variance of 1. One more term to write. We are running out of space here, so I'm going to write a minus here and write out the last term, which is going to be this multiplied with this here. This is going to give us W2 times W2 is W2 squared times R2 times covariance between 1 and 2, and this all is equal to 0. Now let us see if we can cancel out something. We look at this term here and we look at this term here. So let's strike them off, because this one is a plus and this one is a minus. We also see that there is a 2 times W1 W2 times R1 times covariance 1 2, and there is this term W1 W2 R1 covariance 1 2. So let us see what we are going to be left with. We have this term. Let's write that W2 squared times R1 times variance of 2 plus this minus this is going to give us only one such term, W1 times W2 times R1 times covariance between 1 and 2. What else do we have? We have this term here, which is W1 times W2 times R2 times variance of 1. And we also have this term W2 squared times R2 times covariance between 1 and 2. This is all equal to 0. Let us see what else we can do. We can collect like terms together. There are some terms with W2 like this and like this, and there are two terms which have W1 times W2. So let us write them out. W2 squared times R1 times variance of 2 minus W2 squared times R2 times covariance between 1 and 2. And let us take the W1 and W2 terms over to the right hand side. So what we are going to have is W1 times W2 times R2 times variance of 1 minus W1 times W2 times R1 times covariance between 1 and 2. Let us now see what else can be done. Let us take W2 common from both sides. So what we have inside the bracket now is W2 times R1 times variance of 2 minus W2 times R2 times covariance between 1 and 2. Let us do the same thing on the right hand side. W1 times R2 times variance of 1 minus W1 times R1 times covariance between 1 and 2. This means that this W2 can be struck off with this W2. Now we still have W2 running into our framework, so we are going to substitute 1 minus W1 for W2, and let us see what happens. So we can write 1 minus W1 times R1 times variance of 2 minus 1 minus W1 times R2 times covariance between 1 and 2. This is going to be equal to W1 times R2 times variance of 1 minus W1 times R1 times covariance between 1 and 2. So from here we could have taken out W1 as common. So let us do that. Or let us do that in this very step itself. Let me just erase this, and we can write the term again by taking W1 common. So we can say W1, and inside the bracket we are going to have R2 times variance of 1 minus R1 times the covariance between 1 and 2. Let us see if we are getting somewhere. Let us multiply out the terms here first. When we multiply this term, we are going to get R1 minus W1 times R1 times variance of 2 minus, let us see what we get here. We are going to get 1 times R2 covariance 1, 2 is going to give us R2 times covariance 1, 2, and we are going to have minus W1 times R2 times covariance 1, 2, and this is going to be equal to the same thing here, W1 times R2 times variance of 1 minus R1 times covariance between 1 and 2. Let us open out this bracket. Alright, this is looking much more simpler. Now let us examine this and see what else can be done. Looks like, dealing with so many terms, there is again an error here. This R1 was supposed to be the result of 1 times this whole thing. So this has to be R1 times variance of 2. So let me make that correction before we move on. So here we were supposed to have R1 times variance of 2, and R1 times the variance of 2 was supposed to be here as well. Let us rewrite this to see if this can get any simpler. R1 times variance of 2, and I'm writing the R2 item here, minus R2 times covariance between 1 and 2, and then these two terms are there, and both of them have a W1, so we can take W1 common, and inside we are going to have R1 times variance of 2 minus R2 times the covariance between 1 and 2. The right hand side remains unchanged. Now let us see what is possible. We can take this W1 term over to the right hand side so that all W1 terms are on one side of the equation. So we will have R1 times variance of 2 minus R2 times covariance between 1 and 2 is equal to, we have this term already here, so W1 times R2 times variance of 1 minus R1 times covariance between 1 and 2, and we take over this term also to the other side. Now things are looking brighter. So there's a W1 here and there's a W1 here. So W1 can be taken out as the common factor, and we can write the rest of the stuff inside, which is R2 times variance of 1 minus R1 times covariance between 1 and 2 plus R1 times variance of 2 minus R2 times covariance between 1 and 2. And now we are looking at the definition of W1 already. So W1 is going to be equal to R1 times variance of 2 minus R2 times covariance between 1 and 2 divided by R2 times variance of 1 minus R1 times covariance between 1 and 2 plus R1 times variance of 2 minus R2 times covariance between 1 and 2. We can write this in a slightly better format because we see in the denominator there's a covariance 1, 2 here and a covariance 1, 2 here, so we can collect these terms together. So the numerator is the same, and in the denominator I'm going to write out this term first. It seems logical that we start with R1, that's why. Then I'm going to write the R2, and then I'm going to take the covariance between 1 and 2 common. When I do that, I'm going to have this R1 inside the bracket, and I'm going to have this R2 also inside the bracket, and we have covariance between 1 and 2. This is the optimum weight W1, which means that W2 is equal to 1 minus W1. So we have just maximized the Sharpe ratio for a 2 asset portfolio. The derivation is pretty lengthy and complicated, and when you are attempting it, be very careful, because it is very possible that we can forget a term or two, or we can forget a 1 or a 2 or a plus or a minus. So be very careful and do it deliberately and slowly. You saw that I also made a couple of errors on the way, but as long as we recognize the errors and correct the mistakes, we are going to be okay. See you next time.